Hello everyone, this is Dhavala. Let us discuss about part 2 of module 2, which is geodetic survey. In geodetic surveying, we will be learning about principle, classification of triangulation system, selection of baselines and stations, orders of triangulation, triangulation figures, reduction to center, and selection and marking of stations. Coming to geodetic survey, we know that geodetic survey is one of the primary classification of survey, the other one being plane survey. Plane survey is the extent where the geoidal shape of the earth is not taken into account, whereas in geodetic survey, geoidal shape of the earth is taken into account, and all the lines that are drawn between any 2 points will be considered as curved lines, and all the angles between any two lines will be taken as spherical angles. Now, this figure clearly shows that the lines connecting AB, BC, and CA, we have a straight line as well as a curved line. This angle will be considered as a spherical angle, and we also have normal plane angle between A, B. Similarly, the same angles gets repeated at point B as well as at point C. Now, what is geodetic surveying? It is to determine very precisely the relative or absolute positions on the Earth's surface of a system of widely separated points. Now, how do we find out relative or absolute positions? The relative positions are determined in terms of length and azimuths of line joining them, and the absolute positions are determined in terms of latitude, longitude, and the elevation of the point above the mean sea level. However, the distinction between geodetic surveying and plane surveying is fundamentally one of extent of area rather than of operations. The precise methods of geodesy are followed in the field work of extensive plane trigonometrical surveys also. Since the area embraced by a geodetic survey forms an appreciable portion of the surface of the Earth, the sphericity of the Earth is taken into consideration while making the computation. Geodetic work is usually undertaken by the state agency, and in India it is taken by Survey of India department. Now, what is triangulation? We have something called as triangulation, which is a part of geodetic survey, that is to establish triangulation. Sorry, in triangulation, it is a system of number of interconnected triangles in which we have something called as baseline, and the length of baseline will be measured, and we have number of angles which we will be measuring in triangulation. Here is a rough sketch to give you a brief idea of how a geodetic survey or a triangulation runs. Here we can see there are n number of interconnected triangles over here. Now, more about triangulation. This is a rough sketch to indicate how a triangulation system runs. We have A, B, C, D, E, F all joining to form interconnected triangles. We have a line AB which is called as baseline. All the apexes of triangles will be called as triangulation station. So in the given sketch, we have A, B, C, D, E, and F as triangulation stations. The entire set of the figure will be called as triangulation system or a triangulation figure. We have something called as subsidiary base or check base, which is the line EF. These are formulated in the case where, while computing, if there are any errors which follows from A, B, C, D, E, F, we get to check whether there is any error, something needs to be corrected or not. And AB is the baseline. This is the only line whose measurement will be measured, linear measurement will be measured. All other lengths AC, BC, AD, CD will be computed based on the angles measured at A, B, C, D, E, F respectively. Now, before going ahead, let's see what is the objective of a geodetic triangulation. The main objective is to provide the most accurate system of horizontal control points on which the less precise triangles may be based, which in turn may form a framework to which other forms of surveys like cadastral, topographical, hydrographical, engineering may be referred, and to assist in determination of the size and shape of the earth by making observations to latitude, longitude, and gravity. Now, coming to the next point, which is classification of triangulation. It is basically classified into primary, secondary, and tertiary, which in other terms, it can also be called as first order, second order, and third order triangulation systems, respectively. The first order triangulation is of the highest order and is employed either to determine the Earth's figure or to furnish the most precise control points to which secondary triangulation may be connected. The primary triangulation system embraces the vast area, usually like the whole country gets covered up in primary triangulation system. Every precaution is taken in making linear and angular measurement while performing the reductions. Coming to secondary triangulation, it consists of number of points fixed within the framework of primary triangulation. The stations are fixed at close intervals so that the size of the triangles formed are smaller than the primary triangulation one. The instruments and methods used are not of the same utmost refinement when compared to that of primary triangulation system. Now, coming to third order or tertiary triangulation system, even this consists of number of fixed points within the framework of secondary triangulation system and forms the immediate control for detailed engineering and other surveys. The sizes of the triangles are smaller and the instruments need not be of highest precision as required for primary and secondary triangulation. Now, here is a tabular column which shows the difference between primary, secondary, and tertiary. The key points which differentiates or by which the triangulation can be classified are average triangle closure, wherein we have less than 1 second for primary, 3 seconds for secondary, and 6 seconds for tertiary triangulation system. And coming to maximum triangular closure, which is allowed in a primary triangulation, is not more than 3 seconds, and 8 seconds in secondary, and 12 seconds in tertiary triangulation. Now look at the length of the baselines. Primary runs from 5 to 15 kilometers, whereas a secondary is 1.5 to 5 kilometers, and tertiary forms about 0.5 to 3 kilometers. And what are the lengths of sides of a triangle that is allowed in case of primary triangulation system is 30 to 150 kilometers in primary, 8 to 65 secondary, 1.5 to 10 kilometers in tertiary. What are the actual and probable error of the base allowed? 1 in 3 lakh and 1 in 10 lakh for a primary triangulation system. Look at the error probability you can give while doing the measurement. This is why the word precise is used when primary triangulation system is carried out. Discrepancy between two measures of a section. What is meant by two measures of a section is you can measure a distance from point A to B as well as from point B to A. What is the discrepancy allowed is 10 millimeter for a square root of a kilometer in case of primary, 20 in case of secondary, and 25 in case of tertiary system. And probable error of computed distance is 1 in 60,000 to 1 in 2,50,000, 1 in 20,000 to 1 in 50,000, 1 in 5,000 to 1 in 20,000 in case of tertiary triangulation system. And dear students, this tabular column needs to be studied very well. Now, coming to how do we go ahead with the figure, or how do we choose a triangulation figure? Here we have got 4 different sets of figure, that is single chain of triangles, double chain of triangles, central point figures, and quadrilaterals. This is single chain of triangles. Here we have got double chain of triangles. Here we have got central point figure and braced quadrilaterals or also quadrilaterals. Single chain of triangles is used where a narrow strip of terrain is to be covered. Though the system is rapid and economical, it is not so accurate for primary work since the number of conditions to be fulfilled in the figure adjustments is relatively small. Also, it is not possible to carry the solution of triangles through the figures by two independent groups. Thus, it becomes not so necessary to be used in case of primary triangulation. Coming to double chain of triangles, it is used to cover a greater area. Coming to central point figure or centered figures, it is used to cover area and give very satisfactory results in flat country. The centered figures may be quadrilaterals, pentagons, triangles, hexagons with central stations. That is clearly shown over here in this sketch. A, B, C, D forms a triangle. A, D, F, G forms a quadrilateral with E as the central figure. G, H, I, J, K and F forms a pentagon with H as its central figure. Now coming to quadrilaterals. The quadrilaterals with four corner stations and observed diagonal forms the best figure. They are best suited for hilly countries since the computed lengths of the sides can be carried through the system of different combination of sides and angles. The system is most accurate. Coming to how and when to choose or the criteria for selection of a figure. The figure should be such that the computations can be done through two independent routes. Also, the figure should be such that at least one and preferably both routes should form a well-conditioned triangle. And all the lines in a figure should be of comparable length. We should be avoiding very long lines. The figures should be such that least work may secure the maximum progress. And complex figures should not involve more than 12 conditions. In very extensive survey, the primary triangulation is laid in two series of chains of triangles, which are usually placed roughly north and south and east and west respectively. Now we have something called as gridiron system and central system used in triangulation survey. This is the activity for you guys to look at what a gridiron system is and central system is in a triangulation survey. Now let us see how does one carry out triangulation survey or the steps involved in triangulation survey. We have reconnaissance survey. Reconnaissance survey, like the definition says, a surveyor or a team of surveyor goes, checks the area to be surveyed and makes note of all the key points required for the triangulation survey. Next is erection of signals and towers. As soon as reconnaissance survey is carried out, the places where the equipments are to be stationed will be the points will be stationing signals and towers. And we measure the baseline. Measurement of baseline with highest precision and accuracy is to be carried out. All the angles required are measured with highest accuracy. Horizontal angles measurement, which was learnt in theodolite survey, comes handy over here. It is either done with the help of repetition method or reiteration method. Astronomical observation at Laplace stations are taken. Laplace stations are nothing but the check stations used to measure the accuracy of previous stations carried out. Last comes the computations. After measuring the length of the baseline and horizontal angles, all the remaining lengths will be computed as a office work. How do we select a triangulation station? In the previous slide, we saw something about erection of signals and towers. Similarly, we need to select a triangulation station. The point, how do we select a triangulation station? The triangulation stations should be intervisible. For this purpose, it should be placed in such a place where it can command a large number of points. For example, such as hilltops, so that long sights through undisturbed atmosphere may be secured. They should form well-shaped triangles or well-conditioned triangles. That is, no angle should be less than 30 degree nor greater than 120 degree. Preferably, it is advisable to choose an isosceles triangle or an equilateral triangle. The stations should be easily accessible and should be such that the supplies of food and water are easily available, so that camping ground near or our nearest suitable accommodations are available. They should be so selected that the length of the site is neither too small nor too long. Why is this so? Small length of site will result in errors due to centering and bisections, while large line of sight will make the signal too indistinct for accurate bisections. So preferably the length should be of equal, neither too long nor too short. They should be in a commanding situation so as to serve as the control of the subsidiary triangulation and for possible future extension of the principal system. The systems of the subsidiary triangulation should be such that they are useful for detailed surveys as well. In heavily wooden country, the stations should be so located that the cost of clearing and cutting are as much minimum as possible. The stations should be situated so that the lines of sights do not pass over towns, factories, furnaces, etc. Why is this? Because of it should not be creating any refraction effects because of irregular atmosphere. Now, having seen all these things, we will continue in the next class regarding other points like reduction to center and etc. Thank you.